Now measure right down the bearing of B from A. Okay, so B is where we need to go, and we're going to start at A. Okay, so we're going to start at the A, and we need to go to B. Now bearings are always measured from north, and we always do the bearings in a clockwise direction. Okay, so this is the angle that we need to work out from here all the way around here. The easiest way to do that is to measure the inside angle here and minus it from 360. That's one way of doing it. Now if you measure that angle should be an angle of, okay, we got about 29 degrees. Okay folks, what did we get for that first one, number one?
29.
About 29.
Yeah.
Okay, so that was an angle of 29 degrees. So if we do now 360 degrees and we minus the 29 degrees, that will give us an answer of 300. Whoa, very funky 3. Okay, that's the 300 volts and 31 degrees is the answer for part A. Okay. On the diagram, draw a line on a bearing of 103 degrees from A. Now, okay folks, I don't have anything to measure the angles with, so I'm going to do a sketch. We'll have to measure it. I'm going to rub some of this other stuff off first, because it's actually in the way. Okay, let's rub some of this stuff off here. Okay. So, let's draw a line. So you need to measure measure bearing of 103 from A. So A, face north and go 103 degrees round. So I'm going to do a sketch of it. You need to measure properly. Okay, so I'm saying that once you've measured it, so that should give you an answer here of 103 degrees. Oh, that's my pen. Okay, let's go back. Oh, that's not nice. It's flicking between pen and hand. Okay, 103 degrees. Okay, 103 from A. And that will give us the line that we need. And that's the end of question number 1. Question number 2. Okay, question number 2, I'm going to move it up a bit. So I'll have to clear that. Go to that, move it up. Let's make it a bit bigger. Oh, that's much better. Okay, question number 2 goes right on the bearing of X from P. So X from P. So we start at P, we face north, and we go towards X. And that angle has already been measured for us on the diagram, which is 65. But it wants a bearing. Bearings are, number 1, measured from north. Number 2, bearings are always clockwise. Number 3, bearings always have 3 digits. So even though this is 2 digits, we have to write it as 3. So 0, 65 is the answer for that one. Next one, work out the bearing of Y from P. Let's get rid of all this stuff over here first of all. Okay, we need to clear the diagram for the next question. Okay, bearing of Y from P. So we're going to start at P and go to Y. Because we go to where's the from. So go to P, start at north, okay, and go towards Y. So the angle that we are looking for is, let's draw a line on this first of all. Let's make it green. So we're looking from here and here. So the angle that we're looking for is the angle. So we need to work out this angle here. That's the angle that we're looking for. And as we can see from the diagram, this angle and this angle together makes 360. So if you want to work our angle here, the green one, we do a calculation which is going to be what? 360 degrees. We minus the 140, and that will give us the green bearing angle that we need. So 360 minus 140 gives us an answer of 220. Bearing is always in 3 digits, and that's already in 3 digits. It's 220 is the answer for this angle here, and I will write it in black. So the bearing is 220. The green angle, I'll just get rid of this for the moment, just so we're not getting confused with that. So all of this green angle is 220, and that's the answer for 2, and that's the end, also the beginning of the paper, all done. Okay folks, hope these questions help you with the examination preparation, and helps my students to pass along. Thank you. See you in the next video, inshallah. Bismillah. Right, so we're on this question over here at the moment, which is question number 3 on bearings. So that back over here. So that distance here, that green distance that we measured, the students have measured it, and we've come to a measurement of, was it 14.3 centimeters. Now we know that the scale here is 1 centimeter for 1 kilometer, so that means that the, oh, I'm going to do a straight line. 14.3 kilometers. Okay. Okay, that's 14.3 kilometers. Now the next part of the question says, because use a ruler and protractor to work at the distance we just done. We just done the distance. And the bearing of the journey from Z to X. Now, quickly just mention that this distance, it varies from the one in the mark scheme. The one in the mark scheme says 15.1 is definitely not 15.1, is 14.3. I've checked it myself. Now the bearing of the journey from Z to X. Now, if you want to measure the bearing of the journey from Z to X, we need to then measure, let's have a look. Which way do we face first of all? We have to face in which direction for bearing? You have to face first of all, oops, doing the wrong color. Just change color. We're going to do from Z, and we're going to go towards X. So we start in the north direction here. Okay, that's all I can fit in at the moment in my current diagram. So we face north, and then we have to go all the way around until we get to the X line. So we need to know that angle there. Now that angle there, because everything is drawn to scale, it is drawn to scale. We can measure that angle. Yeah, normally it says not drawn to scale, so you do calculations. Here we need to do a measuring exercise. So, students, which one of you guys measured that red angle there for me? Okay, that big angle is going to be a nice big angle. Well, if you go straight, that's 180. It's about 200 and something. Okay, Samara, what have you got for the angle? 247 is absolutely bang on to what the mark scheme has got. So that's 247 degrees. Now, for those of you who haven't measured it, I want you to measure it now. So don't just assume that answer is correct. I want you to do it yourself. I want everybody in the room to come to that conclusion that that angle is 247. So this angle here, the red angle, is 247. And one way you could do that is, you can measure the inside angle, which is this one here. Okay, you can measure this one and minus it from 360. That's one way of doing it. Okay, or you could draw a line straight down, that's 180, and then add on the extra bit. So there's lots of different ways of doing it. Now, tomorrow, that's a good answer there, 247. And that's exactly in tune with the mark scheme. And I'm happy with that. Okay, are we happy with that, folks? We're ready to move on?
What about 241?
241, that's a bit too far. That's 6 degrees out. You need to get a bit more of an accurate answer. Try again. Be a bit more accurate. You need to make sure. Go on, what you got? 46 is good. Okay, folks, I'm going to clear the page and move the page. So we got question number 4 in full view. Okay, question number 4. And helicopter. Wow, that's good grammar. And helicopter. A helicopter. Okay. A helicopter flies due north from X to Y, starts from here and goes to Y. The distance from A to B on the river is 24 miles. Okay. So now the distance from A to B is, I think this A to B is supposed to be on the river. Okay. This A to B is talking about X and Y, isn't it? Because it's starting and going to there. Yeah, so I think here, I think this from X. The river starts here, goes along here, goes to Y. The distance along the river is 24 miles. So we can change those, correct them and do a bit of editing. There's another mistake on here as well, but they got one of the characters wrong. Okay, so this part here, Z is 12 miles northeast of A. There's not even A on the diagram. And that is actually referring to what? The X. So I think there's going to be 1 or 2 typing errors on the actual original paper I gave you. So apologies for that, folks. So if there's any confusion. Now the question says here, we have a scale of 1 centimeter represents 2 miles. Now what we need to do, we need to measure the distance from here to here, and that will give us, hang on, let me double check that with you. That distance is given as what?
8.1.
8.1
centimeters.
Okay, won't be. Hang on a second. 1 centimeter represents 2 miles. So, hang on a second. Should you get. You got 8.1 centimeters. Okay, lovely. That's good. So, this distance here with the ruler, the student has measured it as 8.1 centimeters, and that is bang on right. So, 8.1 centimeters is the measurement on the map, but we know the scale is each centimeter is worth 2 miles. Whoops, I think I've gone over that a bit too much.
So do you times by 2 then?
That's right, absolutely. So we have here, the scale is what's going to help us work at the next part. So 8.1 multiplied by 2. Okay, now I'm doing my funny lines now. 8.1. So 8.1 times by 2 will give us 16.2 miles. Lovely answer. If you got the answer, folks, that's where we need to be. Okay, are we happy with that? We measured that distance. We've doubled it tomorrow. Okay, Mr. Hassan doubled it, yeah? 8.1 centimeters times by 2. Okay. Now, it says there Z is 12 miles northeast of X. Now, let's have a look. Okay, never eat shredded meat. That's what we learned in school. It's not actually a bad thing to learn. Never eat shredded meat. Shredded meat is very good for your health. So I don't know why we learned that for. So he went in the northeast direction. So a northeast direction means that we went in that direction. Okay? And northeast direction has a very definite bearing of what? 0, 40. What's the bearing? 0.45, because that's 90 altogether, that's halfway, exactly, is the northeast. Okay? So we now need to draw a line starting from, remember here they made a mistake here earlier, so it's starting from X, it goes right down the 3-figure bearing, so the 3-figure bearing is nice and straightforward. What is it? I just told you on the top.
45.
No, not 45, 0.45. Remember, a 3-figure bearing has 3 figures. So, if you don't put the 0 in the examination, it is absolutely wrong. It is wrong. You get nothing. It's only worth 1 mark anyway, that one. Now what they want us to do, they want us to draw that on. Now at the moment I don't have any tools for drawing, for measuring angles, but I'm going to sketch it on there and you have to measure it. Okay, we draw a line. We draw a red line. So we start from the X facing north. And we go in a 45 degrees direction. Okay, before I've done it already. Okay, I'm gonna stop there. Okay, mark. So, okay, I need to be rubbing because I got things in my way. Let's get rid of this for a moment. Okay. Let's put the measurements back in. That was 8.1 centimeters, which became 16.2 kilometers. and brackets. Okay, now it says that it is 12 miles northeast. What is wrong with this pen? Why doesn't it do what I want it to do? Hold on, no, okay, this pen. Okay, it is 12 miles. Now, we have a scale of 2 miles is worth 1 centimeters. So what do we do with the 12 now? So before we have to times, now we have to divide by. So 12 miles is the distance. We want to change it back into centimeters just for the scale. So we do 12 divided by 2. Okay, well that's a really funky 2. So that gives us a distance of 6 centimeters. So we now need to measure from X 6 centimeters, and I'm gonna, for my sketch, I'm gonna say it's here. Okay, but you have to measure it 6 centimeters. So you need to measure 6 centimeters. If you want to, you can rub off the rest of the line and just do 6 centimeters. That would be no problem. So for example, you could say, well, there you go. I've just drawn a 6 centimeter line, and I'm going to put Z at the end of it. There. So that would be 6 centimeters by scale, but in reality, that is representing how many kilometers? 12 kilometers. And this angle here is going to be 45 degrees, but the bearing is obviously 0.45. So you put a bit of extra detail on that question, and that question is completed. Are we happy with that now, folks? Yeah? Good? Okay, let's clear the page, and let's move forward into the next question. Okay, right. Here comes the next question. Right. Okay, the question number 5. The diagram shows the position of 2 telephone masts. X and Y on a map. Measure the bearing of Y from X. Okay, let's get back to 10. Measure the bearing of Y from X. Now, as the question suggests, Y from X. If I said to you, pass me a pencil from the table. So you start at the table and you come back to me and give me the pencil. So the language here tells you where to start from. So we have to start at X. And we have to start in the direction of north and go towards Y. So we need to measure the angle there. Okay, measure the measure the bearing of Y from X. Okay, hang on 1 second, what's happened there? Okay, so we are going to start at X, which is here. And we are going to go towards north and go towards Y. So how to get to Y from X? So has anybody measured the angle from here? About 59, 60, what's 59. Okay, 59, 60 degrees. Okay. Use your sheet measure. Let me quickly check it. Okay, use your protractor.
59.
Yeah, happy 59? Let me just double check that for you. 59 degrees. Yeah, I'll have it 59, so that's good. Okay, that's 59 degrees now. That's the angle that we measured, so that indicates to us that the bearing will then be, bearing always has 3 digits. 0.59. 0.59 is the bearing. Now, in the mark scheme, for those of you who do have access to a mark scheme, they've got a completely wrong answer of 241. Please ignore that, that is wrong. Okay, are we happy with the question 5A? Is that all done, yes?
Yeah.
Happy with that, right. Question 5B, I'm not going to move the page, otherwise might just lose our diagram for the moment. Question 5B says, I think we might be able to move it. So we got the answer, that's okay. I'll have to clear the page really. Clear the page and then move it up a bit. And just be able to see it. That's okay. There we go. Okay, now question part B. Another mass Z is on a bearing of 160 from Y. On the map, Z is 4 centimeters from Y. Plot the position of Z with a cross X and label it Z. So what we're going to do for that one? So we start at Y. We face north, which is that way, and we come around here to an angle of, what is it? 160. So bearing is 160. So I need you to measure for me 160. I'm going to do a sketch of where 160 is because I don't have the tool for measure angle at the moment. If anybody knows where this tool is on the internet, please send me a link. Would be greatly appreciated. So I'm going to draw a sketch of where I think the 160 should be. And I'm going to have a feeling 160 is around about here. So, that's my guess. I want you to measure it, folks. Do not guess yours. So I'm saying this is a sketch of mine, but this should measure on your diagram 160 degrees. And draw a light pencil line along here. 160 degrees. Samara, you got that? Okay, Ifra, Afira?
Yeah.
We're good to go on that one, Hamza? You got that? Right. Lovely. And then he goes there that it is 4 centimeters from Y. Now, is there a scale of a diagram? Well, as he says it's 4 centimeters, so we measure 4 centimeters. So there's nothing to worry about scale as such. So I want you now to measure from here, look at my pencil, to along here 4 centimeters, and then draw across. I'm gonna say the mine is here as, because I don't have the tool for measuring distances either. But you have to measure yours. And I'm gonna rub off the rest of the line. Not that you need to, but I just wanna, so here you go, there's my X. You can have a bigger line as well. So if you still keep your line, that's not a problem. If you want to take the extra bit off, you can take that off as well. That's no problem. That's just, will be counted as a construction line. So if you leave that on, if you leave it on, it's fine going further on. Okay, that's done. So then we have to put a cross there and label it as, what's it called? That point is Z. Okay? So measure 4 centimeters along here, which is this distance here, and label it Z. Job done for that question. Are we all on board for that one? Ready for the next question? Good. Let's clear the page on that. Let's move it, page around a bit. Question number 6. The diagram shows part of a map. It shows the position of a lighthouse and a boat. Here's the lighthouse, here's the boat. The scale of the map is 1 to 10,000. Right. Before we go any further, I need somebody to explain to me what does that mean, because they haven't given us any units. Right. Put your hand up if you got an idea of what that means to you in this question. Okay, don't all put your hands up in one go. Okay, that 1 to 10,000 means whatever one you measure on your diagram here, for example, 1 centimeter, or you measure 1 millimeter, or you measure 1 inch. We don't use inch anyway, but whatever one you measure off, in real life is worth 10,000 of those. So for example, as an example, say from here to here was 10 centimeters. 10 centimeters. Say I measure 10 centimeters. In real life it would be 10,000 times 10 centimeters. And the answer will be in centimeters. And then we can convert it into meters, whatever we need to do. Okay, are you happy with that? So it's 1 centimeter to 10,000 centimeters. We're going to measure in centimeters. Now what I need you to do now for me, folks, is I'm going to draw a line here that connects these X and these X's together. And I would like you to measure, because I can't measure on here. I would like you to measure on your pieces of paper, your examination papers now, please. So I want you to measure the distance from here to there. And I want you to give me the distance in centimeters first of all. Okay, what kind of distance do we have? What do you? 7.7. 7.7. Whoa. Yeah, you get a small paper. Okay, go on. 7.7. Okay, let me have a quick double check of that.
7.8.
7.8. Right, let me just double check, because in the marks you've got something else. 7.8 bang on. I'm going to go for 7.8. Okay, in the examination, the mark scheme, they've got 8.3. Lord, it is this, maybe because the way they've printed the paper. I don't know. Lord, I don't know what's best. Okay, so we are saying that so far, what did we say was? 7.8. 7.8 centimeters is the actual distance from these two crosses. Now, it wants to answer the meter. We need to do 7.8. 7.8. We have to multiply it by, what's the scale? 10. 10 what? 10,000, which is where? Kafira, yeah, it is. Yeah. So every 1 centimeter you measure is what 10,000 times in real life. So 7.8 times by 10,000. Let's go. Alright, so what we need to do now, well, that will change into centimeters, isn't it? Centimeters. Okay, and that will give you then centimeters. But we need the answer in meters. So at the end of it, we're going to be dividing it by 100 to change it back into meters. So what we could do here, we could cancel it now, can't we? So we can cancel this. Divide by 10, divide by 10, divide by 10, divide by 10. So we got 7.8 times by 100. So we go 1, 2. So we copy down the 7, we copy down the 8, and we copy down the 0. Okay, this is not part of my calculation, but it's my answer. I'm just boxing that up. So there's the calculation there. I'm just copying it down, by the way. Maybe I should just copy it slightly further down. Sorry about that, folks. I've kind of mashed into there. Apologies for that. 780 meters. Centimeters converts into centimeters of real life, converted back into meters. Okay, so we times by 10,000 divided by 100, and that will give us the answer of 780. Please ignore the 830 meter answer in the mark scheme if you're following that. That is incorrect. Next, find the bearing of the lighthouse from the boat. So bearing of the lighthouse from the boat. Now remember the wording? So where is this from? That's where you start. So we are going to start at the boat. This is where we're going to start. You can put an arrow there for emphasis, for demonstration. I'm going to start here. I'm going to start at the boat and I'm going to go to the lighthouse. So we face north, which is here. You go up, face north, and then we got to measure this angle here. That's the angle that we need. Okay, that will be a nice big angle. Find the bearing of the lighthouse from the boat. And they've got another mistake in the exam. I don't know what they've been doing this marks. If you want to find out how to get to the lighthouse from the boat, you got to face north, go all the way around till you get to the lighthouse. So that will give you that angle. Now, if you want to work out this angle here, I'm just going to color it in.
Is the angle 180 because it's going all the way around?
No, it's really more than 180 because 180 is just here. 180 is straight down. If you face from north to down, it's 180 is much more than 180. It's going towards 300 or something. So you need to measure now for me, folks, this angle here. I'm just going to color it in while you guys are measuring here with your super duper protractors. But easy way of doing this angle here is to measure the opposite angle instead. Measure this angle here and minus it from 360, and that will be a quicker way, possibly, of getting your answer. So I'm just coloring this in while you guys are doing your work. And it makes it look nice, and I like that. Okay, right. So you can measure this angle instead, and you use that angle minus 360 to give you the angle that we need. This is the angle that we need, folks. So I need somebody to feed me the answer.
310.
Okay, right. 310 small. What do you get? Yours.
228.
Okay, you got 228. Okay, no, the angle won't change though. And you got 310. Any more for any more? Hamza, what you got? 310.
I got 312.
Okay, 312 is close to 310. Okay. Hassan, I need an answer from you. You got 310. Okay. Right. Right. Now, what was this angle here? First one, who got this angle is? 50. If that angle is 50, then 360 minus 50 will give you definitely 310. So 310 is the correct answer of the bearing of this item from this item. It is bearing 310. Please ignore the mark scheme answer of 130. It is incorrect. So this is the correct answer. The correct answer is 310 degrees, and it is a 3-digit bearing. 310. Okay, are we happy with that, folks in this room? Yes?
Yeah.
Anything you want me to go back through? Okay, good. Are we good to move forward? Right, let's clear the page. Let's move forward. I think we have the last question. Did we do all elements of that previous question? We've done all elements of it, yeah? Yeah, okay. Here comes the last question. Okay. Bismillah. Right. The diagram shows the position of two ports A and B. Okay, after we finish question number 7, I'm going to quickly go back and just quickly do question 1 and 2 because we missed the answer in the video. We'll just quickly do that part at the end. The diagram shows the position of two ports A and B. A ship sails from port A to port B. Now, here we go. Let's look at some key pieces of information. So, Hassan, the key piece of information is?
1 centimeter represents 50 kilometers.
Which is the scale. Yeah? So, things happen. Nobody says diagram not to scale. This one is to scale. And that is the scale. Measure the size of angle marked X. Now, that should be something that shouldn't really cause too much of a bother. Now, has anybody measured? I'll actually highlight it for you, which angle they want you to measure. They want you to measure this angle here, X. Right, can somebody give me a measurement for that angle?
131.
131. Any others? Any more? 131. Okay, 131. I'm going to come and double check that. So the answer is, I'll just double check that. It is 131, even though the mark scheme's got 130. I'm going to go for 131. Okay, work out the real distance between port A and port B. Use the scale. They just mention the scale again. Now, okay, folks, what I want you to do now, I want you to measure this distance. For me, please. That distance A to B in centimeters is equal to 5.6 centimeters is my first response here. Okay, Hamza? 5.6. Hassan?
I got 5.67.
Okay. So we have 5.6 centimeters is the actual distance in real life. Now, what we need to do, 5.6 centimeters, we need to multiply it by 50, because each centimeter is represented by 50 kilometers, and then we need to park a kilometer sign at the end of each story got there. So what is 5.6 times by 50?
280.
280. Okay. Anybody else work that out? Can somebody confirm that calculation for me, please? 5.6 times by 50. You do 5.6 times by 100 and divide it by 2. Which looks right. Lovely. Okay, I'm going to go for that one. Right. The next part of the question, without moving the page, I'm going to read it. On the diagram, mark A port C with a cross X. Label it C. And port C is 350 kilometers on a bearing of 060 from port B. Again, I'm going to do a sketch, folks. You need to do the measurements. Is that clear, yeah? So here we go. I'm going to use a different color now for my line. So from port B, we have to do 60 degrees now. Now, let's tell you, okay. So remember, if you do a bearing, you start at north, from north.
So we'll do 60 degrees.
And you got to measure from here. Whoops. You got to measure 60 degrees. 60 degrees here. 60 degrees. Okay, right. Now, the next part of the calculation. Now, we have 350 kilometers. Now, folks, let's have a look. 350 kilometers. We need to change the 350 kilometers back into centimeters. So before we were timesing by 50, now we have to divide it by 50. Okay, the scale is 1 centimeter represents 50 kilometers. So that will give us an answer of. So in our scale calculation, it will give us. Whoa, getting funky lines here. That is not supposed to be like something cranky 7, but that's a 7. Okay, let's just try and write that again. Okay. 7 centimeters is the answer. So I need you now to measure from here. Look where my pencil is on the screen. From B, I want to measure 7 centimeters, and I'm going to say for the sake of argument that it's here. And you're going to label that an X there and a big C for airport C. And I'm done. So I've just done now 7 centimeters. Let me get on the rubber. Pardon me, folks. Okay. Okie dokie. All we have, also the beginning of the paper, all done. Okay, folks, I hope these questions help you with the examination preparation and helps my students to pass along. Thank you. See you in the next video, inshallah.